The three tech trends to watch. AI is a smokescreen. While the entire world is hypnotized by large language models and image generators, three other technological revolutions are quietly building momentum. These are not small, incremental updates. They are fundamental platform shifts that will redefine how we interact with the physical world, our own biology, and our infrastructure. Focusing only on AI is a strategic error. It's like watching the cavalry charge while ignoring the artillery being set up on the hills. This briefing is designed to correct that error. We are going to deconstruct three specific, under-the-radar tech trends. For each one, we'll break down the core system, analyze why it matters now, and identify the strategic window of opportunity. Forget the noise. It's time to focus on the signal.
The spatial web. The first trend is the evolution of the internet from a network of pages into a network of places. This is the spatial web. Forget the metaverse hype. This isn't about creating a cartoon virtual world to escape into. It's about anchoring digital information directly onto the physical world we already inhabit. It's a new layer of reality accessed through devices like smart glasses or even your phone. Think of it like this. The first version of the internet, Web 1.0, was a library of static documents you could read. Web 2.0 became interactive. You could write back. The spatial web, or Web 3.0, lets you interact with data that is mapped onto physical objects and locations. We're already seeing primitive versions of this. A QR code on a restaurant table that pulls up a menu. A social media filter that puts a mask on your face. An augmented reality app that lets you see how a new sofa would look in your living room. These are the early, clumsy prototypes, version 0.1. So why is this a critical signal right now? Because the hardware and software are finally converging. For years, the processing power, battery life, and display technology weren't ready. Now they are. Devices like Apple's Vision Pro are not the final product. They are the developer kit for this new platform. They signal to the market that the core technology is viable. Simultaneously, we have global 5G for low-latency data transfer and advanced sensor technology like LiDAR built directly into our phones. The back-end and the front-end technology have finally synced up. The strategic opportunity here is not in entertainment. That's the obvious low-margin play that everyone will chase. The real value is in high-stakes, professional applications where data precision is non-negotiable. Imagine a surgeon. Instead of glancing back and forth between the patient and a 2D monitor displaying an MRI scan, they see a real-time 3D holographic overlay of that scan directly on the patient's body. The digital information is fused with physical reality, reducing cognitive load and the potential for error. Or a jet engine mechanic. They look at the engine and their glasses highlight the exact bolt that needs tightening, displaying its required torque specification right next to it. The instruction manual is no longer a book, it's an interactive layer on the machine itself. This is the key. The spatial web wins by making complex physical tasks more efficient and less prone to human error. The opportunity isn't in building another game. It's in building the unsexy, high-value software for surgeons, engineers, and logisticians. This is the next user interface. We went from text commands to a graphical desktop with icons. We are now moving from a flat screen to a spatial environment. The operators who build the critical tools for this new interface will own the next decade of software.
The biological interface. For decades, we've treated the human body like a black box. We measure inputs like food and sleep, and we measure outputs like performance and health. But the processes happening inside are largely invisible in real time. Wearable technology was the first crack in that box, giving us lagging indicators like heart rate and sleep phases. The biological interface is the next logical and final step. It's the shift from wearing technology to integrating it. This isn't about science fiction, it's about creating a direct, high-bandwidth data link to our own physiology. Think of it in layers. The first layer is already here, continuous monitoring. Devices like real-time glucose monitors for diabetics were the prototype. They proved the core concept. When you have a live, constant data stream from your own body, you move from being reactive to being predictive. You don't just fix problems, you see them coming and prevent them entirely. This layer will expand to monitor hormones, immune markers, and nutrient levels, turning personal health into a pure data science problem. The second layer is active intervention. This is where the system stops just reading data and starts writing it. Imagine a device that detects the specific neurochemical cascade that precedes a migraine and emits a precise electrical frequency to neutralize it before you ever feel a symptom. Or an implant that regulates cortisol levels in real time to manage stress with the precision that no meditation app could ever achieve. This is closed-loop biological regulation. The final layer is the neural interface, the direct link to the brain. This is the endgame. Companies like Neuralink are building the foundational hardware right now. The first applications are restorative, giving control back to people with paralysis. But the long-term application is enhancement. A direct cognitive interface isn't about uploading your consciousness, it's about offloading computation. It's like having a calculator, but instead of typing in the numbers, the query and the solution happen at the speed of thought. It's a co-processor for your brain. The strategic opportunity here is not just in the hardware. That's a capital-intensive game. The real play is in the software, analytics, and security for this new biological operating system. Every human will become their own data platform. The companies that can securely analyze that data and build applications to optimize it will define the next frontier of human potential. This isn't about turning into a machine. It's about finally gaining full access to the machine you were born with.
Decentralized infrastructure. Our digital world is built on a dangerously fragile foundation. Major cloud providers like Amazon Web Services, Google Cloud, and Microsoft Azure run the majority of the internet. When one of their data centers has a problem, entire sections of the global economy go dark. This is a critical vulnerability. It's a centralized system with a single point of failure. It's also a monopoly that sets prices and controls access to the digital rails of our society. The third major trend, decentralized infrastructure, is a direct answer to this problem. The core principle is simple. Instead of building massive centralized infrastructure from the top down, you build it from the bottom up, using hardware contributed by a network of individuals. Think of it like Airbnb for digital hardware. Airbnb didn't build any hotels. It created a software protocol and an incentive system that allowed people to monetize their unused spare rooms. Decentralized infrastructure applies the exact same logic to things like data storage, wireless bandwidth, and computing power. Here's how the system works. A protocol, often built on a blockchain, acts as the coordinator. It's the rulebook and the marketplace. Then, a digital token is used as the incentive. If you contribute a resource, like unused space on your hard drive, you earn tokens. If you want to use the network's resources to store a file, you pay with those tokens. This creates a self-sustaining economy without a central company taking a cut. The incentives of the users, the operators, and the developers are all aligned toward a single goal: build a better, more resilient network. This isn't theoretical. It's happening right now. Look at Filecoin. It's a decentralized storage network. Instead of trusting your data to Dropbox or Google Drive, which store it on their centralized servers, Filecoin encrypts your data, splits it into pieces, and distributes it across thousands of computers all over the world. The result is a storage layer that is cheaper, more secure, and cannot be shut down by a single entity. Look at Helium. It created a decentralized wireless network for Internet of Things devices. Individuals buy a small hotspot, place it in their window, and provide network coverage to their area. In exchange for providing that coverage, they earn tokens. Helium built a nationwide network in a fraction of the time and cost it would take a traditional telecom company. Or consider HiveMapper. It's building a decentralized global map to compete with Google Maps. Drivers install a special dashcam, and as they drive, they map the world. They are rewarded in tokens for the data they contribute. This creates a constantly updated, ground-level map built by its own users. This is the key takeaway. Decentralized infrastructure isn't just a new technology. It's a new economic model for building the physical world. It directly challenges the monopolies that currently own our digital foundations, creating systems that are more resilient, more open, and more equitable because the users who build the network are also the owners. This is the ultimate form of leverage.
The future isn't one single event. It's a set of parallel systems coming online. While the mainstream is fixated on the obvious, The operators who understand the spatial web, the biological interface, and decentralized infrastructure will be the ones who build and command the next decade. You now have the tactical overview. The next move is yours. This is the strategic analysis we deliver at Capital Sanctum. If you want to operate ahead of the curve, subscribe and activate notifications.